Good afternoon, students. My name is Mr. Steenerson, and in this lab, we're going to determine the speed of sound, so the speed of a wave we cannot see, using our understanding of waves and tubes, and also a tuning fork. So here's the basic setup. When I strike a tuning fork, it's creating sound waves that vibrate the air molecules around it and are sent out in all directions. What we're going to do is we're going to hold that tuning fork over this open tube, and as we pull it out of the water slowly, the sound waves that are coming off of the tube some of them are traveling down into the tube, and then they hit the surface of the water and they bounce back. This emulates a closed tube. So when we listen and hear for the reflected wave to start to cause a resonant sound, we hear that as an amplified tone. So the tone actually gets louder. We'll hold the tube at that point where it resonates, where it gets louder. That is the first harmonic, the first time that it resonates, and we know that that is 1/4 of a full wavelength. So using that measurement and the frequency on the tuning fork, we'll be able to work backwards and find the speed of sound traveling through air in this room. For this setup, I've chosen 6 different frequencies, ranging from 512 hertz all the way down to 256 hertz. I also have the tube suspended in water, and while I'm doing the demonstration, I'll call out which frequency I'm using, and I'll hold the camera steady so you can read off the measurement on the tube. Each one of these marks is a centimeter. So this would be 5 centimeters, 10, 15, 20, and so on. So you'll be able to look and see if the water level matches up with 20, for example, then that is the distance from the top of the tube to the water level for that resonating sound. The first tuning fork is 512 hertz. Resonance here. The next tuning fork is 480 hertz. Resonance here. The next tuning fork is 384 hertz. First resonance here. The next tuning fork is 341.3 hertz. First resonance here. The next tuning fork is 288 hertz. Resonating here. The last tuning fork will be 256 hertz. Resonating here. Okay, at this time you should have collected the length measurements for 6 different frequencies. I'd like you to create a data table, and using that data table, graph the relationship and then work to calculate the speed of sound. You can find the lab manual and the lab write-up on the assignment in Schoology. Please reach out if you have any questions. Thanks, and have a great day.